today we're gonna do greatest common factor using prime factorization. All right, to find the greatest common factor, there's two ways to do it. One, you can just list out all the factors and figure out which one's bigger, or you can do it this way. All right, so what I'm gonna do is I'm gonna make a factor tree. So 2 and 28, 2 and 14, 2 and 7. Now all of the factors on my factor tree I'm just going to write out. So 2, 2, 2, 7, 2, 2, 2, 7. Now I'm going to come over to this factor tree, or this number, and do a factor tree for it. 2 and 23. That's it. So I write that out. So now I have to ask myself, what do these two have in common with their factors? Well, this has a 2 and this has a 2. Do they have anything else in common at all? No, they do not. So my greatest common factor is then just 2. All right, I'm going to show you a lot more examples, so don't worry. All right, here's our second one. We're going to find the greatest common factor of 170 and 210. So I make a factor tree, 2 and, just use your calculators, it's 85, then 5 and 17. All right, so 17 is a prime. All these numbers on the outside are prime, so I'm done. Now I'm going to make a factor tree of 210. 2 and 105, and then 5 and 21, 3 and 7. So my numbers here are 2 times 3 times 5 times 7. Now I want to see what they have in common. So, or their factors. That has a 2 and that has a 2. This has a 5 and this has a 5. So does this have a 17? No. So 2 and 5 are my greatest common factors here. So I take those two, 2 times 5, and all I have to do is multiply them together. And that gives me 10. So 10 is my greatest common factor. So all I'm doing is making a factor tree for each of the numbers, writing down all of the prime numbers, or the factors of them, for each, and I see what matches up. When I find out what matches up, I multiply them together to get my greatest common factor. All right, here's our third one. So we're going to find the greatest common factor of 180 and 540. So I know 2 and 170, 2 and 135, 5 and 27, 3 and 9, 3 and 3. So my factors here are 2 times 2 times 3 times 3 times 3 times 5. So 2, 2, 5, 3, 3, 3. All of those are factors that lead up to 540. Now 180. 2 and 90, 2 and 45, 5 and 9, 3 and 3. So I get 2 times 2 times 5 times 3 times 3. I'm going to put that in order. And there you go. So now all I have to do is find out which factors match up and multiply them together. Use my blue marker. So this one has a 2. This one has a 2. This one has another 2. This one has another 2. This one has a 3. 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 That one's out of 3, so I mark it off. And that has a 5, and that has a 5. So I'm going to multiply them all together. So 2 times 2 times 3 times 3 times 5, because that's what they have together. And that gives me 4, 9, 36 times 5, 180. So 180 is my greatest common factor. of 540 and 180.
There you
All right, for this one, we're going to find the greatest common factor of these two. These are already broken down into factor. These already been factored out, and they're put in exponential form. So all we have to do to figure this out, and how I do it, is I just pick the base that matches on both, and then I take the lowest exponent. So this is 2 to the 5th, this is 2 to the 3rd. Which has the smaller exponent? 2 to the 3rd. This has a 5 as a base, this has a 5 at the base. What's lower? 1 or 2? 1. This has an 11, this has a 7, so we don't put anything else in. So that is our answer. If you wanted to do it out, it'd be 8 times 5, and 40 is the greatest common factor of whatever this is. But that's how you break it down. You just look, match the bases, and use the lower exponent. All right, here's another one with just variables. You do it the same exact way because the base doesn't matter. So I have m to the 7th and m to the 1st. What's smaller? M to the 1st. Now I have n to the 4th and n to the 12th. Which one's smaller? N to the 4th. And I have p to the 3rd and p to the 5th. What's smaller? P to the 3rd. So all you have to do is match up the bases, and the smaller one is your answer. So that's how you do that one. All right, here's your 6th example. This is a mix of numbers with the variables and their exponents, and we're just looking for the greatest common factor here. So we do the same thing we've been doing with the numbers. Don't get too confused with it. Yeah. All right, don't worry about the negative sign in front of it. All right, so now we just write out what we have. So 2 times 5 times 5, and 2 times 2 times 2 times 5. Now we want to see what matches up. So I have a 2 here and a 2 here. I have a 5 here and a 5 here. Do I have another 5 over there? Nope. Do I have another 2? Nope. So I have a 2 and a 5. 2 times 5, 10 is our greatest common factor. But that's not the end of it. I have to do my variables also. So I have an m to the 4th and an m to the 2nd. What is my smaller exponent? M to the 2nd. Now I have n to the 7th and n to the 10th. What's my smaller exponent? N to the 7th. And that is your greatest common factor of negative 50, m to the 4th, n to the 7th, and 40, m to the 2nd, n to the 10th. This really isn't that difficult. Just keep it simple and you'll be all right. I'm going to do one last one. All right, here's our last problem. This is number 7. But we have 3 different terms this time, and so you're just going to find the greatest common factor. So make a factor tree. Don't worry about that right now. I'm going a little bit quicker. So right here I have 2 times 2 times 2 times 2. Here I have 2 times 2 times 2 times 2 times 2. And here I have 2 times 2 times 2 times 2 times 3. So 4 2's and a 3, 5 and 4. So now I want to find what they have in common. This has a 2, this has a 2, this has a 2. This has a 2, this has a 2, this has a 2. This has a 2, this has another 2, this has a 2. This has a 2, this has a 2, and this has a 2. Now since there's no more 2's here or anything else, they all can't have anything in common. So just mark the rest of it out. And now I'm left with 4 2's. So 2 times 2 times 2 times 2, 4 times 4, 16. So 16 is the first part. Now we just have to do the rest of it. A to the 4th, 3rd, 2nd. The smallest one is a to the 2nd. And then 4, 5, and 6, b to the 4th. And that is your answer. This has been greatest common factor using prime factorization. I hope it helped and good luck.